So, we've already talked about arithmetic sequence. Geometric sequence is, so arithmetic sequence is when you have a common difference, which means you're adding or subtracting in the same pattern. Whereas geometric sequences, you have a common ratio. And this common ratio is what you're multiplying by each time in the sequence. So it's not adding or subtracting, it's multiplication. And they're rather similar. Well, they're not similar at all, but in the idea of the recursive formula versus the explicit. Remember, the recursive formula is used when I really only want to find the next term or the third term or the fifth, something that's not too far away. And then the explicit formula is used when they want me to find like the 30th term or the 50th or the 1000th. So it's a quick shortcut. But the hardest part about the explicit is you have to have it memorized. Well, let's break it down. The recursive formula only tells you what the first term is and what your common ratio is, what you're multiplying by each time. That's all it does. And it helps you figure out, well, okay, what's the next term or what's the third term? Explicit formula is set up where it's a sub 1, which is your first term, times your common ratio raised to the power of n minus 1. Okay, so if you can't tell what you're multiplying by each time, then it's rather similar to the common difference. I'm going to take my second term and divide it by my first term to find that common ratio. So let's first decide if it is a common ratio or not, okay? If it's a geometric sequence or not. Are we multiplying or dividing by the same thing each time? So number 1, is it a geometric sequence? Am I multiplying by the same thing each time? Well, number 1, it looks like I'm multiplying by 3 each time. Well, let's double check. Is 12 times 3 36? Yes. Is 36 times 3 108? Yes. So since it is a common ratio each time, this is a geometric, so yes, and my common ratio would be 3. Number 2, it looks like at first, from 5 to 10, I am multiplying by 2. Well, am I multiplying by 2 each time? 10 times 2 is not 15. So this is not geometric. This is actually arithmetic. And the reason why it's arithmetic is because I'm actually adding 5 each time. So that my common difference would be 5. Number 3, do I have a common ratio? Is this a geometric sequence? Well, am I multiplying by the same thing? So to get from 120 to negative 60, I am multiplying by negative 1/2. Am I multiplying by negative 1/2 each time? Well, let's check. Negative 60 times negative 1/2 is positive 30. 30 times negative 1/2 is negative 15. So yes, this is a geometric sequence, and my ratio would be negative 1/2. So don't think that geometric sequences are only multiplying by an integer. It could be multiplied by a decimal or a fraction. Number 4, is this a geometric sequence? Well, let's check. From 1 to negative 4, I would be multiplying by negative 4. But am I multiplying by negative 4 each time? Well, negative 4 times negative 4 is positive 16. 16 times negative 4 is negative 64. So this is a geometric sequence, and our common ratio would be negative 4. Number 5, at first glance, I really couldn't tell you what I could be multiplying by to get from 50 to 35. So let's check. Take my second term, divide it by my first. So my common ratio would be 0.7. Or is it? Well, let's check. 35 times 0.7 is 24.5. So this is not a common ratio because I'm not multiplying by 0.7 each time. So this is not geometric. Let's see if it's arithmetic. Arithmetic means I'm adding or subtracting by the same thing. Well, 50 to 35 is minus 15. 35 to 20 is minus 15 also. So this one is actually arithmetic because my common difference is negative 15, subtracting 15. Number 6, from 625 to 125, what am I multiplying by? Well, to be sure, I would do my second term divided by my first term. So it looks like I'll be multiplying by 0.2. Well, let's double check. Is 125 times 0.2 25? It is. Is 25 times 0.2 5? it is. So this is a geometric sequence because I'm multiplying by 0.2, and my ratio would be 0.2, or if they convert it to a fraction, would be 1/5. So you got to be prepared for either decimal or fraction. Now, let's talk about the difference between recursive and explicit. Recursive, of course, is if you are just wanting the next term or the next 3 terms, something real quick. So all you have to do is continue the pattern. Well, let's first look at number 7. My pattern starts 4, then 8, then 16. Assuming that these are geometric, let's figure out what the common ratio would be. So from 4 to 8, I'm multiplying by 2. But am I multiplying by 2 each time? 4 times 2 is 16, so I am. So my common ratio is 2. So I'm just going to continue the pattern. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. There you go. Number 8, my common ratio, let's see, from 1 to -6, I would have to multiply by -6. Well, let's make sure I'm multiplying by -6 each time. -6 times -6 is positive 36, so I am. My common ratio is -6. So 36 times -6 is -216. -216 times -6 is 1,296. 1,296 times -6 is -7,776. Number 9. From 486 to 162, I do not know what the common ratio would be off the top of my head. So I'm going to do the first or the second term divide by the first. So my common ratio looks like it's 0.3 repeating. Obviously, I don't want to leave it a decimal like that. So 0.3 repeating, if we want to convert it to a fraction, would be 1/3. But am I multiplying by 1/3 each time? Well, 162 times 1/3 is 54, so I am. So to continue that pattern, 54 times 1/3 is 18. 18 times 1/3 is 6, and 6 times 1/3 is 2. So that's the recursive. The explicit formula is whenever they want us to find a term down the line, and it would probably take us too long to figure out that term by doing it one at a time. Of course, you're more than welcome to if you can't remember what the formula is, but let's break it down. To find the nth term that they're asking for, we're going to take the first term times the common ratio raised to the power of n minus 1. Well, first things first, we need to figure out what the first term is. So for number 10, my first term is 5. Then we need to figure out what the common ratio would be. What am I multiplying by each time? Well, 5 to 20 would be times 4. Am I multiplying by 4 each time? Well, 20 times 4 is 80, so I am. So my explicit formula is the first term times my common ratio, which is 4, raised to the power of n minus 1. So the difference here is my n minus 1 is raised to the power. So since they're asking for the 8th term, I'm going to do 5 times 4 raised to the power of, substitute n for 8, so 8 minus 1. So my 8th term, if I were to continue this pattern, would be 81,920. Number 11, first we find the first term. So my first term is first listed, so 1536. My common ratio, if I can't think of it off the top of my head, I do the second term, divide by the first, and that's 0.5. Now you're welcome to leave it 0.5, or you got to be prepared to see it as a fraction, so they're probably going to use 1/2. But let's write it. So I take my explicit formula, which is the first term, 1536, times my common ratio. Again, you can put 0.5 or you can put 1/2. Raised to the power of n minus 1. Since they want the 7th term, I do 1536 times 1/2. Again, you can totally do 0.5 raised to the power of, since they want the 7th term, I do 7 minus 1. So my 7th term, if I were to continue my pattern of halving everything, would be 24. Number 12, they want the 10th term. So first we have our first term, which is -2. My common ratio, what am I multiplying by each time, looks like would be -5. So then I write my rule. My first term is -2 times my common ratio, which is negative 5, raised to the power of n minus 1. Now here's the part you have to be careful with. Since my common ratio is a negative, if I want to raise to the power of that negative, I need to put the negative in parentheses. Because if I don't, and this exponent ends up being 2 or 3, I need to tell the calculator that it's negative 5 raised to the power, not just 5 and then tack on the negative. So let me show you, because let's see if we do get a different answer. If I do 10 minus 1 there, so negative 2 times negative 5 raised to the power of 10 minus 1, there's that answer. Whereas if I'm do what I'm supposed to and put negative 5 in parentheses raised to the power of 10 minus 1, I do get the same answer. But where you have the trouble is whenever it's a positive exponent. So if we see another one, I'll go over it again. So my answer is ginormous. It is 3,906,250. Let's practice a few more. So number 13 is asking for the 9th term. Our first term is negative 65,536. My common ratio, if I can't think of off the top of my head, I do 16,384, the second term, divided by the first term. So it's negative 0.25. You could use it as a decimal, or you can convert it to a fraction, which would be negative 1/4. So my first term is negative 65,536 times my common ratio, so negative 1/4 raised to the power, raised to the power of n minus 1. So again, I'm going to show you both with parentheses and without. It's supposed to be with parentheses when it's a negative, so let's see what happens if I don't. So I have negative 65,536 times, again, I'm going to put parentheses to begin with because you're supposed to when it's a negative ratio, and then raised to the power of 9 minus 1 because it is the 9th term. So I got negative 1 as my answer. Well, let's see what happens when I forget the parentheses and see if it makes a difference. And this time it does. So there's negative 1 and there's positive 1. So be extra careful. With the parentheses, it is negative 1. Number 14, my 11th term. So my first term is 6. My common difference, or common ratio, my apologies, looks like would be times negative 3. So I take my first term times my common ratio. Again, since it's negative, I'm going to put in parentheses, raised to the power of n minus 1. So 6 times negative 3, parentheses, raised to the power of 11 minus 1, means my answer would be 354,294. Number 15, the 7th term. So the first term is negative 1. My ratio looks like would be positive 7. So my first term times my ratio raised to the power of n minus 1. Since they want me to find the 7th term, I do negative 1 times 7 raised to the power of 7 minus 1. My answer would be negative 117,649.